Remote-controlled drones have exploded over the past couple of years to become one of the biggest hobbies worldwide. This market came to our minds last September when we thought, well, what if you could have a dogfight from a drone? Now, we couldn't use actual bullets or missiles to accomplish this. The FAA might be less than thrilled with that idea, but we could put a miniaturized laser tag system on a drone. The idea was to create a completely immersive experience that would make it feel like you were on a gunship trying to shoot down your opponents. The system would have a first-person view video camera and IR LED co-aligned on a turret that could be controlled wirelessly by the user to simulate an in-flight aerial battle. The team has spent the last 2 semesters designing the turret system, wireless video relay, and remote control, utilizing a Raspberry Pi and a custom PCB to provide power regulation and peripheral interface. There were quite a few speed bumps along the way, but we are happy to say that now we have a fully functioning prototype.
The project concept is a remote-controlled first-person laser tag turret system. This system is intended to be paired with an existing drone. Video and game data will be transmitted from the turret to the controller. The controller will take joystick and other user input and transmit back to the turret. When a user fires, the laser will emit a pulsed pattern from an infrared LED. This message, if properly aimed, will trigger opposing systems to decrement a health bar. When the health bar goes to 0, the game is over.
The following specifications were defined for this prototype. If we could meet these specs, then a more refined product could be marketable in the future. The system had to be able to engage targets as far as 50 feet away. It had to weigh less than 200 grams so that most medium-level quadcopters could carry it. And finally, the video latency could not exceed 100 milliseconds, or else acquiring targets could get quite frustrating. Here is a demonstration of our system meeting the range of engagement requirement. The crosshairs on the user interface turn red when the system fires. That signal on the oscilloscope is what the sensors report back to the system, and that means that this test was successful.
Our system was able to meet the weight specification of 200 grams or less. Meeting this allowed the drone carrying our system to play the game without greatly affecting its performance and battery life. By keeping weight low, it broadens the potential customer base for the users of our system.
Latency had been specified to be less than 200 milliseconds. Through a Wi-Fi router, it was difficult to achieve anything less than about 200 milliseconds. In future versions, peer-to-peer networks may reduce this latency.
In the end, our system is able to provide an interactive, first-person experience for a drone laser tag game. By being lightweight, modular, and usable over Wi-Fi, we've been able to create a unique and fun addition for drone pilots everywhere.